Now the third step that we are going to see is repolarization. When we said that the membrane of the nerve fiber is electropositive outside, it is electronegative from the inside. This membrane is said to be the polarized membrane. Polarized membrane. Now when a stimulus is given to this membrane, when the stimulus is provided, we saw that this charges, they change because of the sodium ions. The sodium ions, they come inside the membrane, and the charges, they change. The inner side becomes electropositive and the outer side becomes electronegative. This positive charge is because of sodium ions. So as the sodium ions, they come in, the inner side of the membrane becomes electropositive and the outer side becomes electronegative. Here we said that the impulse was generated. This impulse is conducted from this point, one point on the membrane to other point on the membrane through the loops. Now suppose here first point is electropositive from outside, electronegative from inside. The impulse was generated here on the third point. Now this impulse has been conducted from third to fourth point. So here the charges or the membrane or the point, the third point will again become repolarized. It will gain the positive charge from the outside and inner side will again become electronegative. Whereas the fourth point will become electronegative from outer side and electropositive from inner side. So here the impulse, we said that the impulse had travelled from third point to fourth point or one point to another point. Now this membrane, after the generation and travelling of impulse, this membrane is said to be depolarized. When the outer side was electropositive, the inner side was electronegative, it was polarized membrane. When the charges changed at a point, it is said to be depolarized membrane. Now how this happens in this diagrammatic representation, we will see. Now here this is the sodium channel voltage gate through which the sodium ions enter. Now if the stimulus is given, suppose if the stimulus is given, if the stimulus was given, we said that the voltage channel gates, they had opened after the stimulus was received. So from here, the sodium ions which were present inside, those sodium ions, they came in. The sodium ions, they came in. Now after this, what happens? When the impulse travels from one point to another point, at that time what happens? This sodium ion, it travels from one point to other point. So here, as the sodium ions, they entered inside, here it became electropositively charged and outer side became electronegative. The sodium ions, as they entered through the sodium channel voltage gates, the inner side became electropositive, the outer side became electronegative. Here we said that the impulse was generated and the membrane has become depolarized. Now what happens? The membrane, these channel gates, they are present. Now suppose this is the membrane. It is a flat membrane and the channel gates, they are present in this way. In this way, if we see it like this, it will look like this, but when we are seeing it in a flat surface, so we will only see one channel at a time. So here it looks like this. So this is the sodium channel gate, this is potassium channel gate, this is sodium potassium pump. So in this way it looks like this. So here this is the sodium channel, this is the potassium channel, and there are sodium and potassium pumps which are present on the membrane. So through sodium channel, the sodium ions, they enter inside. After the stimulus is given, the channel gates they open, the sodium ions they enter inside, and the inner side of the membrane becomes electropositive, whereas the outer side of the membrane becomes electronegative. Here we say that the membrane has become depolarized. Now what happens once the sodium ions they enter inside? After that, what happens? As these sodium ions they enter inside, the impulse has been generated. When the impulse travels from one point to another point, when the impulse moves from one point to another point, what happens? Here, these sodium channel gates, they close down. The sodium channel gates, they close down, whereas the potassium channel gates, they open. The potassium channels they open and the sodium channels they close down. So what happens here? Whatever potassium ions which are present over here in the neuroplasm inside the membrane, these potassium ions they go out, or they move out, or they are thrown out. So the outer side of the membrane again gains its positive charge. The inner side again becomes negatively charged. But this time, the positive charge of the membrane is because of the potassium ions, not because of sodium ions. At the beginning, when the membrane was polarized, the positive charge was because of sodium ions. And after the repolarization, the positive charge, the outer side of the membrane, it gains the positive charge again. As the potassium ions they move out through the potassium channel gates, outer side of the membrane becomes electropositive because of potassium ions, and the inner side again becomes electronegative because of the negatively charged proteins which are present in the neuroplasm. Here we say that the membrane has been repolarized. The membrane has been repolarized. But this repolarization is because of the potassium ions. The positive charge which the outer side of the membrane has gained again, that is because of the potassium ions, not because of sodium ions. Now even if at this situation, at this point, even if another stimulus is provided to the membrane, there are no sodium ions present outside now this time. There are no sodium ions present outside. Only potassium ions are there. So even if the sodium gates open, no sodium ion is going to come in because there are no sodium ions. Only potassium ions are there, and the positive charge is because of potassium ions. Even when the stimulus is given, the sodium channel gates they will open, but there is no sodium ion present over here. So even if the channel gates open, no ion will be passed through it. No ion will pass through it or move through it inside, because sodium ions are absent, and the positive charge is because of potassium ions. So this is called as repolarization. Even the stimulus is given, the impulse will not be generated because sodium ions are absent over here. The positive charge is because of potassium ions. Once in the beginning, in the normal case, this is at resting state. This is at the state of rest. This is the action state. This is at the state of action potential. Now, in the previous part, we discussed about the action potential. This was the resting state, and here the resting potential was minus 70 millivolts. The resting potential was minus 70 millivolts. When the stimulus was given, at that time the impulse has been generated. When the stimulus was given, the voltage was received, and the resting potential, it changed into the action potential, that is minus 55 millivolts. We have seen this through the graph. As the voltage increases, it goes to 0. From 0 it goes to plus 45, and the action potential is up to plus 45 millivolts. Now here what happens at plus 45 millivolts, what happens? The sodium channels, they close down. Plus 45 millivolts, this is the action potential. The plus 45 millivolts, the sodium channels, they close down. Sodium channels close. As the sodium channels, they close down, the potassium channels open and the potassium ions are moved out. And the membrane gains its electropositive charge. The outer side of the membrane gains its electropositive charge again. So this is called as repolarization, or the membrane gets repolarized. So, but here, as the membrane gets repolarized, the positive charge is because of potassium ions, not because of sodium ions. And the negative charge is again because of the proteins, negatively charged proteins which are present inside the neuroplasm. This is the repolarization state.